Good afternoon. Are you able to hear me clearly?
Yes, sir.
Please join with your school email ID and not with personal email ID. I cannot admit everyone. Someone tries to every time telling is not good, no? The board is clear. Is the board clear? Okay. So it's already time. I'll not wait for others to come. Let's start. So in the last class, we had just started with what is inverse, and we had defined what is inverse of a matrix. And I had said that there are two different ways of finding out the inverse. So one was on the basis of the definition, where we said that A into B is equal to either I is the identity matrix, then B matrix will be called as inverse of matrix A. And one more, I had given that inverse of a matrix is 1 upon determinant of A into adjoint of A. So this we'll do later on. This we see in the topic of the transformations. आपका क्लास कितने बजे? मेरा 6:30 बजे तक फर्क क्या था? There are two different ways of solving. So this we'll see later on, which is called as transformations. So this will be the last topic of this chapter, and this is the adjoint. In the last class, we also saw how to find out an adjoint of the matrix. So on the basis of that, we'll do, which is much easier method and which will require less time. Okay, so we have already learned this method. So we'll start solving the numerical, how to use the adjoint method and find out inverse of a matrix. We'll start with a very simpler one. I'm taking a 2 by 2 matrix. Okay, matrix 1, 2, 3, 4. First, I'll do with the method what we have learned, and then I'll give you a simple trick also. If it is a 2 by 2 matrix, you don't even need to solve it. You can directly write the inverse. What is the inverse? But first, we'll do by the regular method, and then we'll see the trick. Okay, so the formula says that inverse of a matrix is nothing but 1 upon determinant of A into adjoint of A. So first we'll have to find out determinant of A. So for 2 by 2 it's very simple. Your determinant will be nothing but 4 into 1 minus 2 into 3. That is nothing but minus 4 minus 6. Students, please use your school email ID. Every time I will not be able to admit you. Okay, I won't be able to admit you every time if I am writing on the board. Use your school email ID so that I don't have to admit you. Okay, so I've got the determinant of A. Now next is to find out adjoint of A. First, let us see the method and then we'll see a very short trick also which we have for this. So adjoint of A, if you remember, it is nothing but minor, okay, with the sign which I had given you in the last class. So first let's find out the minors. So M11. So this element is of the first two and the first column, that is written as M11. So when we need to find out the minors, we have to cancel that row and that column. So what remains? Only 4. Then M12. So when you find out minor of the first row and second column, you have to cancel the second row and the first row and second column. So which element remains is 3. Then M21. So that is just a minute. Are you guys able to hear me properly? Is my voice audible to you?
Yes, sir.
Clear, no? Okay, okay. So, when I'm writing M21 means second row and first column, so I am going to cancel second row and the first column. So, what remains is 2. So, I'll write 2 over here. When I write M22, so this element is in the second row and second column. So, I'm going to cut second row and second column. What remains is only 1. Now, minus, okay, when I give the sign convention, that becomes my cofactor. So, cofactor matrix, if you remember what sign convention I gave, plus, minus, minus, plus. If you don't understand, then I've already said you can write Aij is nothing but minus 1 raised to I raised to j of Mij. So my A11 will be nothing but minus 1 raised to 1 plus 1. So minus 1 square is going to give me plus. Therefore, this is plus. This sign, so this is 1, 2. So 1 plus 2, that is 3. Minus 1 raised to 3 is going to be minus 1. Hence minus sign. Same is 2, 1 power is 3, 2, 2 power is 4. Hence this is positive. Okay. So now we'll get M11 is 4, M12 is 3, M21 is 2, and M22 is 1. So I've got the cofactor matrix. Adjoint is nothing but adjoint of A is nothing but transpose of cofactor. I'll take cofactor matrix and I'll take transpose of that. So I'll get adjoint of A is equal to this row 4 comma minus 4 and minus 3 will become column, and this row 2 1 that will become column minus 2 1. So this is my adjoint of A. Now if you pay attention, okay, if you pay attention on this adjoint of A and this matrix A, this trick works only for 2 by 2 matrix. Okay. So you just have to swap these elements in the principal diagonal, and okay, for the non-principal diagonal you just have to change the sign. Here change the sign. So for 2 by 2 matrix, when you have to find out inverse of a matrix or adjoint of a matrix, you just remember this trick. Okay, swap the principal diagonal elements and only just change the sign. If it is negative, it will become positive, and if it is positive, it will become negative. Okay, just swap the elements of the principal diagonal. So here it was 1 and here it is 4. So it became 4 and this became 1. And here you only have to change the sign. Okay, so here it was plus 2 plus 3, and here I've got minus 2 and minus 3. Okay, it will become very easy. For 2 by 2 matrix, this technique works. So I'll get inverse of matrix is equal to 1 upon determinant of A. Determinant of A we had got plus minus 2 into adjoint of A. Adjoint of A is 4 minus 2 minus 3 1. So this is inverse of my matrix. So matrix A was 1 2 3 4, and inverse of a matrix is 4 minus 2 minus 3 1 into 1 upon minus 2. Okay. So this is how you can find out inverse, which is a very easy method. And for 2 by 2 the trick works very nicely. Let's see one more. Let's take one more. There is a matrix B. And in the last class, before the lecture got ended. If you remember, I just said that you have to check the determinant value. If the determinant is 0, that will be called as a singular matrix. In that case, the inverse does not exist. So you just have to cross verify. If you are not getting 0, then only you have to move ahead. Okay. So let's just directly apply the short technique which I just explained you. How will you get adjoint of B? You are not going to solve now. You have to swap these elements of the principal diagonal elements. So this will become, here it will be 5, here it will be 3. Let me give this is -1 and 4. And you just have to change the sign of the non-principal diagonal. So if this is -1, I will write 1. If this is 4, I will write -2. So this is my adjoint, and determinant of B will be nothing but 15 minus -4, so that will become 15 plus 4. That is determinant of B is 19. Therefore, inverse of matrix B, that is B inverse, will be nothing but 1 upon determinant of B, which is nothing but 19, into this adjoint of B, which is 5, 1, -4 and 3. This is a very simple and easy trick to do the adjoint inverse. Okay, just swap the elements of principal diagonal and change the signs of non-principal diagonal. So in one step itself, you got the answer. Okay, let's see 3 by 3 matrix. 2 by 2 matrices are always easy. Let's go for 3 by 3 matrix. Let me consider a matrix A, 1, 3, 2, 3, 1, 2, and 1, 2, 3. Okay, I have a matrix something like this. Let's find out the inverse for this matrix. Again, the formula to find out inverse is, okay, 1 upon determinant of A into adjoint of A, and for adjoint, to find out adjoint of a matrix, we require a cofactor matrix, and for cofactor matrix, we require minors of a matrix. So first, let's find out minors. So M11. So cancel first row and first column. What remains is 1, 2, 2 and 3. Then M12. So cancel first row and second column. So what remains is 3, 2, 1 and 3. Then M13. So cancel first row and third column. So what remains is 3, 1, 1, 2. Then M21. So I have written M21. So now you will have to cancel row number 2 and column number 1. So the elements which remain are 3, 2, 2 and 3. M22. So I will have to cancel second row and second column. So what remains is 1, 2, 1, 3. So I'll write 1, 2, 1, 3. Then M23. So you have to cancel second row and third column. So you get 1, 3, 1, 2. 1, 3, 1, 2. Then M31. So you are going to cancel third row and first column. So you will get 3, 2, 1, 2. Then M32. You will have to cancel third row and second column. So when you cancel third row and second column, you get 1, 2, 3, 2. And then M33. So you have to cancel third row and third column. So you get 1, 3, 3, 1. So let's find out the minors. This is the first numerical I am doing for inverse. Therefore, I am showing you the method in detail, and then we'll start using little bit shortcuts, because for numerical you have only 2.5 minutes to solve in your exam. Okay, if I want to solve all 30 questions, I have only 1.5 minutes, 2.5 minutes with me. Therefore, I will have to find some shortcuts and I will have to practice and increase my speed. So remember that. Even if you know how to solve it, you will have to work on your speed and accuracy. So 3 into 1 minus 2 into 2, so it will become 3 minus 4. 3 into 3 minus 2 into 1, so that will become 9 minus 2. So 3 into 6, first we have to go from left to right and then from right to left, so 6 minus 1. So this will give me 9 minus 4. This will give me 3 minus 2. Here 2 into 1 minus 3. This will give me 6 minus 2. This will give me 2 minus 6. And this will give me 3 minus 3. So I get minus 1, 7, 5, 5, 1, minus 1, 4, minus 4 and 0. So I've got the values of minors. So I'll write the minors, okay, with the sign conventions, which we will call it as a cofactor matrix. So if you remember, okay, I have said you first put all the positive signs in diagonal, in both the diagonals, principal diagonal as well as, okay, non-principal diagonal. And on the remaining places, you put negative signs. Okay, now put the elements. M11 is minus 1, so plus minus is minus, so this will become minus 1. M12 is 7, so this will become minus 7. M13 is 5, so this will become 5. Then M21 is 5, so this will become minus 5. Then M22 is 1, so this will remain 1. Then M23 is minus 1. Minus minus becomes plus, so this will become plus 1. M31 is 4, so this will remain 4. M32 is minus 4. Minus minus becomes plus, so this will become plus 4. And then M33 is 0. So this is 0. So I have got the cofactor matrix. Now you just have to find out transpose of cofactor matrix. So cofactor matrix transpose. So rows will become columns and columns will become rows. So minus 1 minus 7 5 is row. So minus 1 minus 7 5, this will become a column. Minus 5 1 1 is row. So this will become a column. Minus 5 1 1. Then 4 4 4 is a row. So 4 4 4, this will become a column. So I have got transpose of cofactor matrix, which is nothing but we call it as adjoint. So we have got adjoint of A. So let's substitute into the formula. So formula says that inverse of A is 1 upon determinant of A into adjoint of A. So here we have got adjoint of A. Now to find out determinant, again there is no need to solve it again and again. Okay, you can use the sign convention of any of the row, and whichever row sign convention you are using, okay, use that element of this cofactor matrix. The elements of the cofactor matrix are denoted by small a11, small a12. This small a11 is our original matrix. Cofactor matrix is capital A. Okay, sorry, this capital A, and small a is for this A matrix. So you can apply sign convention and you can write A11 into A11 minus A12 into A12 plus A13 into A13. You can take the middle row also. If you remember, sign convention for the second row was minus plus minus. Then here you will write minus, here you will write plus, and here you will write minus. Again for the third row, the sign convention was plus minus plus. So again what I have written for the first row, plus, minus, then plus. Okay, capital A are the cofactors and A11 are the elements. So cofactors over here. So my A11 is -1, so I'll write here -1 into, here A11 is 1, then minus A12. My A12 is -7, so minus minus will become plus, so 7 into A12. Value of A12 is 3 plus A13. Value of A13 is 5, so I'll write 5 into A13, small A13. Here it is 3. So it will become -1 plus 21 plus 15. So I'll get the value of determinant of A as 20 plus 15, that is 35. So let's substitute in this. So I'll get, therefore inverse of A is 1 upon 35 into this adjoint of A. We have got it as -1, -5, 4, -7, 1, 4, and 5, 1, 0. Everyone has understood how to solve. If you have not understood, then you can unmute yourself and you can tell me. I'll explain it once again. Everyone has understood how to find out the inverse. Okay. Okay then. Let's move ahead. Let's see some more numericals. So now I am not going to show this detailed method which I have shown. I am going to skip some steps. Okay, and the skipping of the steps is necessary because if I want to complete my numerical in 2.5 minutes, then I will have to increase my speed. We are just doing this preliminary numericals. These are not directly asked in this way in your JEE exam. The similar numericals will be asked in your board exam, where you will have to show the steps and you get enough amount of time. But when it comes to JEE, it will not be such straightforward questions. Okay, those will always be on the properties. We will have to use the properties somewhere. But let us first learn this because we'll have to use this also somewhere over here. Let us see one more numerical. My matrix A is 3, 2, 6, 1, 1, 2, 2, 2, 5. Okay, let's find inverse of this matrix also. So again, the formula will remain same, 1 upon determinant of A into adjoint of A. So let's find out adjoint first. So this time I am going to write minus directly M11. Well, cancel first column 5 into 1, minus 2 into 2, 4. So I will directly write 5 minus 4. Then M12. So cancel first row and second column. So that will be 5 into 1, minus 4 into 4 again. So that is 5 minus 4. Then M13. Cancel first row and third column. So I'll get 2 into 1, minus 2 into 1. So that is 2 minus 2. Then M21. So cancel second row and first column. That will be 5 into 10 minus 6 into 12. So 5 into 2 minus 6 into 2. M22. Okay. So cancel second row and second column. So it will be 5 into 3 minus 6 into 2. So 5 into 3 minus 6 into 2. M23. So I am going to cancel second row and third column. So I'll get 6 minus 4. Similarly, M31. So I am going to cancel third row and first column. So I'll get 4 minus 6. M32. So third row and second column. So I'll get 6 minus 6. Similarly, M33. So I am going to cancel third row and third column. So I'll get 3 minus 2. So I am getting 1, 1, 0, 10 minus 12, that is minus 2, 15 minus 12, that is 3, then 6 minus 4, that is 2, minus 2, 0, 1. So I've got the minors. When I apply it with the sign, it will become cofactor matrix. So we know plus, minus, plus, minus, plus, minus, again plus, minus, plus. Okay, so this will be 1, this will become minus 1, this is 0, then plus minus, this is minus minus, that will become plus 2, then you have 3, then this is 2, so this will become minus 2, plus minus is minus, so this will be minus 2, then this is 0, and this is 1. So I've got the cofactor matrix. Now adjoint of A will be nothing but transpose of cofactor matrix. Your rows will become column and column will become rows. This 1 minus 1 0 will become column. 2 3 minus 2, this will become column. Minus 2 0 1, this also becomes the column. Now determinant of A, I already said A11 and to A12, then you have minus A12 into A12 plus A13 into A13. So determinant of A will be A11, that is 1, into, here I have 3, minus A12 is 2, sorry, A12 over here is minus 1. So minus minus will become plus 1 into, here I have 2, plus A13. A13 is 0, and here I have 6. So I'll get determinant of A is equals to 3 plus 2, that is 5. So I'll get inverse of matrix A is equals to 1 upon determinant of A, that is 1 upon 5, into adjoint of A, which is nothing but 1, 2, minus 2, minus 1, 3, 0, 0, minus 2, 1. Okay, so this is how we can use this method to find out inverse of a matrix, which is very much simpler than the transformation one. In the transformation, we have to apply a lot of logic, we have to think a lot how to cancel, we'll see that later on, and it is tedious for JEE. It is not, it should not be used because it takes time, but for your board exams, they clearly mention in your board exam that find out inverse by using row transformations, find inverse by using column transformations. At that time, if you do this method, you will get it wrong. Even if your answer is right, you will get 0 marks because it is asking row transformation and not adjoint method. So we'll see that when we solve linear equation. Before that, let's do some more numericals. So now we know how to multiply two matrices, how to add or subtract two matrices, and how to even find out inverse of a matrix. So let's solve next numerical. Let's see one more very small topic. Are matrices invertible? So written one matrix, okay, 2, 1, 4, 2, and else the matrix invertible, which means does inverse of a matrix exist? How do you find out the inverse exists? You have to find out determinant. If determinant is non-zero, then the inverse exists. And if the determinant is 0, it does not exist. So let's find out the determinant. The determinant will be 2 into 2 minus 4 into 1. So 4 minus 4, which is 0. So determinant of matrix A is 0, therefore matrix A is not invertible. That is, inverse of this given matrix does not exist. 2, 1, 4, 2. Okay, the inverse does not exist because we get 0, and we had seen over there the formula is 1 upon determinant of A, and if the determinant of A is 0, it will become 1 upon 0, which is infinity, which is not defined. Hence the inverse does not exist. Let's see one more. You have the sec theta, tan theta, tan theta, sec theta. So again, the determinant will be nothing but sec theta into sec theta, that will become sec square theta minus tan theta into tan theta will become tan square theta. Now sec square theta minus tan square theta is nothing but 1, right? 1 plus tan square theta is sec square theta. Therefore sec square theta minus tan square theta is 1. So determinant of this matrix B is 1, and therefore we can say that matrix B is invertible. Okay, so let's go to the next set of numericals. So I have this matrix 1, 2, 3, 4, and it says that if AX is equal to I, then find matrix X. So we have been given with a matrix equation where it is written AX into A into X gives me I, where X is my 2 by 2 matrix. X is a matrix of order 2 by 2, and their multiplication gives me identity matrix. Then how should I find out the matrix X? So I is an identity matrix. So A into X is equal to I. So if I divide, yes, very good. Yes, if I divide by A, then I'll get X is equal to I upon A, which can be written as I into A inverse. Or the same thing can also be written as pre-multiplying by A inverse on both sides, or post-multiplying, whatever. So A into A inverse gives me I. So it will become I into X is equal to I into A inverse. We can write in this form also, or we can write in this form also. So let's do this now. So I'll get X is equal to I into A inverse. That is nothing but A inverse. So can we find out A inverse? Here the A inverse is very simple for 2 by 2 matrix, right? It's very simple for 2 by 2 matrix. You have to swap the positions. Then I'll get adjoint of A. You just have to swap the positions to 4, 1, and you have to change the sign. So that is -2 and -3. Okay, and determinant of A. The determinant of A will be 4 minus 6. That is -2. So my matrix X, which is nothing but A inverse, will be nothing but 1 upon -2, 4 -2 -3, 1. Okay, let's do one similar numerical, but this time I have some other relation. I have AX is equal to B. and matrix B. A matrix is also different. Here my matrix A is 1, 2, -1 and 3, and I have matrix B as 0, 1, 2 and 4. And I have to find out matrix X, and this time it is not given, it is equals to identity matrix. In last case, we directly applied the definition. If A into B matrix is equal to identity matrix, then B is A. So last one was easy. How to do this? Ax is equal to B, where again my X matrix is the matrix of order 2 by 2. Yes. So there are two different ways. Like last time we can do it like last time also. Divide by matrix A. Now you have to pay attention over here when you are doing dividing kind of a thing. Basically last time I wanted to show that only. Either you have to pre-multiply or post-multiply. We have seen that A into B is not equal to B into A for matrices. For normal algebra, this result is fine. AB will be equal to BA. So we don't have to worry about anything. But when I am writing over here something like this, when suppose you are dividing, if you are doing by that method, then will you write it as A inverse B, or will you write it as B into A inverse? That is the problem when we are dividing the thing. Last time I wanted to show that only. And if you write it this way or write it this way, in both the cases you are going to get different answers. Why? Because AB is not equal to BA in matrices, and therefore we avoid avoid dividing in matrices. It's not that we cannot divide, but we are going to divide in matrices. Because if we divide in matrices, we don't know, should we write A inverse into B or should we write B into A inverse. So, first thing, and next, if I multiply by A inverse over here, so either I can do post multiply or I can do pre multiply. So pre multiply means before A, post multiply means after B. So be very sure about that. So if I am writing pre multiplying, so both the sides have to pre multiply. So I am going to write pre multiplied by A inverse. Okay, then I'll write A inverse into X is equal to A inverse into B. So now A into A inverse will become I. We know, okay, by definition A into A inverse is I. So this can be remembered as a formula. So this will become I into X is equal to A inverse into B. Identity matrix into any matrix is the same matrix, right? Like you have 1 in your algebra. So 1 into any number is the same number. Similarly, identity matrix into any matrix is the same matrix. So I into X is going to give me X. So I'll get X is equal to A inverse into B. So first we'll find out the value of A inverse. Then we'll multiply that matrix with matrix B. And then we can get this matrix A. So let's find out A inverse. So for A inverse, first we need to find out adjoint of A, which is simple. We just have to swap the positions of the principal diagonals, and we just have to change the signs of the non-principal diagonal. So plus 2 will become -2 and -1 will become +1. Determinant of A is 3 minus -2. So that will become 3 plus 2, which is nothing but 5. So A inverse will be nothing but 1 upon determinant of A, that is 1 upon 5, into adjoint of A, that is 3 minus 2, 1, 1. So let's substitute the value over here. So I'll get x is equal to A inverse as 1 upon 5 into 3 minus 2 1 1 into matrix B, that is 0 1 2 and 4. Okay. So let's multiply. We have already learned how to multiply two matrices. First row into first column, first row into second column. So that will be 3 into 0, that is 0. Okay, plus 2 into minus 2. So that will become minus 4. Then first row into second column, 3 into 1, that is 3. Minus 4 into 2, that will become minus 8. Then second row into first column, 1 into 0, that is 0. Plus 1 into 2, so that will become 0 plus 2. Then second row into first column, 1 into 1, that is 1. Plus 4 into 1, that is 4. We will get x is equals to 1 upon 5. 0 minus 4, that will be minus 4. 3 minus 8, that will be minus 5. 0 plus 2, that will be 2. And 1 plus 5, that will be 5. So our matrix x will be 1 upon 5 into like this. Or if you want to write, you can also add, because you can multiply 1 by 5 inside. You will get minus 4 by 5 minus 1, 2 by 5 plus 1. So this is one method, okay, which we have done. We found out the inverse and we have done. There is one more method in this case, but it will become a little bit lengthy. Then I'll get the equation. Let us avoid that. But you could have assumed, okay, the elements of x as, okay, x1, x2, x3, x4. And then you could have multiplied it with matrix A, and then you could have equated it with matrix B. Okay, and then when you would have solved the equation, you would have got. So that is also one way of solving. This is also one way of solving. Okay, you can do it as an homework. You can multiply. You can take this matrix A as 1, 2, minus 1, 3, and you can take this matrix X as x1, x2, x3, and x4. And then you would have taken matrix B as this 0, 1, 2, and 4. Then you can multiply this matrix first row into first column, first row into second column. So you will get x1 plus 2x3. Here you would have got x2 plus 2x4. Then here you would have got minus x1 plus 3x3. And here you would have got minus x2 plus 3x4, which is equals to 0, 1, 2, 4. And then you can equate it, so you will get this 1 plus 2x3 is equal to 0. x2 plus 2x4 is equal to 1. Corresponding elements will be equated to corresponding elements. A11 of this will get equated to A11 of this. A12 of this will get equated to A12 of this, and so on. Okay. Here minus x1 plus 3x3 is equal to 2. And from here minus x2 plus 3x4 is equal to 4. So we'll solve this equation to this equation simultaneously. We'll get value of x1 and x3. We'll solve these two equations simultaneously and we'll get the value of x2 and x4. So these are two different methods. Whichever method you find easy, you can go for that. And I'll tell you to go with this. Okay. Instead of solving the linear equations and finding out the value, it's going to take time. Here to find out adjoint, it was very simple. We just have to swap the position, change the signs, and just put it. Okay, whichever method you find easy, you can go with that. Let's see one more numerical. If you guys are not understanding at any point, then please let me know. Let's see one more numerical. So as A is equals to 4, 5, 2, 1. So if A is equals to 4, 5, 2, 1, then which of the following options are correct? Option A is A inverse is equals to 1 upon 6 into A minus 5I. Option B, A inverse is equals to 1 upon 6 A plus 5I. Option C, A inverse is equals to 1 upon 6 A minus 3I. And option number D, A inverse is equals to 1 by 6 A plus 3I. So let's try to solve this and find out which of the options are correct. Okay. So the options, every option is having A inverse and 1 by 6. It means that we will have to find out A inverse first. And let's find out determinant of A. What we get, that will be 4 minus 10. So I'm getting it as minus 6. Okay. And adjoint of A. So adjoint of A, we have already seen a short technique. You have to swap the elements of the principal diagonal and you have to change the signs of the non-principal diagonal. So this will become minus 5, minus 2. Okay. So we get this adjoint of A and we know A inverse is nothing but 1 upon determinant of A into adjoint of A, which is 1 minus 5 minus 2, 4. If we see in the options, everywhere for A inverse we are having 1 by 6, 1 by 6, 1 by 6, 1 by 2. Therefore, what I am doing is I am taking minus 1 common so that this minus sign and minus sign get cancelled. Okay. So I'll get A inverse is equals to 1 upon 6. I've taken minus sign common, so this will become minus 1, minus 5 will become plus 5, minus 2 will become plus 2, and plus 4 will become minus 4. This is the value of my A inverse. He is saying that either of this, it should be A minus 5I or A plus 5I or A minus 3I and A plus 3I. Okay. So what do you think it can be? So let's see. So my identity matrix is 1, 0, 0, 1. Yes or no? So let's take n from there. 5I, A minus 5I or A plus 3I or something. So when I do 5I, I'll get 5, 0, 0, 5. Now we'll get hint from here itself. Okay. We'll get hint from here itself. 4 minus 5 is going to give me minus 1. 5 plus 0 is going to give me 5. So option A. Okay, option A is the answer. Still, if you want, you can just solve it and see. If you do A minus 5I. So A, that is 4 minus 5, that will be minus 1. Then 5 minus 0, that will be 5. 2 minus 0, that will be 2. And 1 minus 5, that will be minus 4. Yes or no? Now for A inverse, you just have to multiply it by 1 by 2. So our answer is option number A. So we have done some standard numericals just to find out, or just to learn how to find out inverse, how to find the adjoint and all. Let's see one more method and then we'll start with the JEE numericals. Before that, we have to see two topics. One topic is transformations, another is solving linear equations. So what this transformation is, I can add any two rows, I can add any two columns, I can subtract any two rows, I can subtract any two columns, I can multiply any row or column with any number, and then I can add with again any row or any column. But row can be added or subtracted with the row only, and column can be added and subtracted with column only. Okay, so all this whatever we are doing, this adding or subtracting rows or multiplying with scalar and then adding or subtracting the rows, is called as transformation. Okay, so first is interchange, which means you can also interchange any two rows or any two columns, and this is shown by this symbol, something like this. So here you show double arrow. So when I say R1 interchange with R2 or C1 interchange with C2, let's see. I have this matrix A, 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I write R1 interchange R3, which means R3 will become R1 and R1 will become R3. But when I do this transformation, I not use equal to sign, I use approximately equal to. Okay, and R1 is getting interchanged with R3. So R1 will become R3 and my R3 will become R1. And second row as it is. Suppose if I write over here C1 interchange with C2. Okay, for this, then I am going to interchange first column with second column. So my first column 1, 4, 7 will become my second column, and my second column 2, 5, 8 will become my first column, and third column as it is. So this is the first transformation, which is called as interchange. Next is we can add or any subtract to rows or columns. Add or subtracting any two rows. If I write this same matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I can do something like this. R1 minus R2. Now try to understand, I am writing R1 minus R2, which means I am going to subtract R2 from R1. It clearly means I am going to subtract R2 from R1, so the transformation is only going to occur in R1. So to tell our mind that the transformation is going to occur only in R1, we write something like this. So what it indicates? It indicates that transformation occurs only over here. And what kind of transformation I am going to do in R1? I am going to subtract R2 from R1. So it means that the transformation is going to occur only in R1 Therefore, only R1 is going to change in the operation. So R2 and R3 remains as it is. So I'll write R2 and R3 as it is. R2 is 4, 5, 6 and R3 is 7, 8, 9. Okay, and what transformation I'm going to do in R1? I'm going to subtract row number 2 from row number 1. So corresponding elements are subtracted. So 1 minus 4, that will be minus 3. 2 minus 5, that will be minus 3. And 3 minus 6, that will be minus 3. If I write something like this, R3 minus say R1, and again, to tell our mind that we don't make mistake, what I'm going to do, I'm going to subtract R1 from R3. And I don't get confused, I write something like this, R3. And what transformation I'm going to do? So the transformation is going to occur only in R3. And what sort of transformation? I'm going to subtract row number 1 from row number 3. So the transformation is going to occur in R3. So the changes will be done only in R3. So R1 and R2 as it is. So my R1 is 1, 2, 3, 4, 5, 6. Okay. Now R3 transformation is going to occur. What we are going to do? We are going to subtract R1 from R3. So subtract R1 from R3. So 7 minus 1, that is 6. 8 minus 2, that is 6. 9 minus 3, that is 6. Similarly, I can add 2 rows also. I can add 2 columns also. I can do something like this also. Suppose I am writing C1 plus C3. So again, what it indicates, I am going to add C3 in C1. The transformation is only going to occur in C1. So it's better to write something like this. Initially, you write like this. Once you get practice, you can use the shortcuts. You can directly write C1 plus C3. That is also allowed. But initially, as we are learning this thing for the first time, for the first few days when you are practice this, then you can stop using it. So the transformation is going to occur only in C1. And what kind of transformation we are going to do? We are going to add C3. So since transformation is going to occur in C1 only, write C2 and C3 as it is. So C2 is 2, 5, 8, 3, 6, 9. And now what we are going to do in C1? We are going to add C3. So add this over here. So 1 plus 3, 4, 4 plus 6, that is 10. 9 plus 7 plus 9, that is 16. Okay, so after transformation, I am going to get this. Now, let's ask one fundamental question to ourselves as how can we do this transformation? What is the base of this transformation? Are we allowed to even do this such kind of transformation in mathematics? The matrix was 1, 2, 3, 4, 5, 6, 7, 8, 9. And after the first transformation, it is becoming, okay, here if I go, after the first transformation, it is becoming minus 3, minus 3, minus 3, 4, 5, 6, 7, and 9. Are both these matrices same? Or if I have done this transformation, the matrix gets converted into 1, 2, 3, 4, 5, 6, 6, 6, 6, which is not same as the original matrices which I had taken. So, how is it possible? And if it is possible, okay, is it right? Is it correct to write in this manner? If you just remember my first lecture in the introduction, I said we had started with the linear equation. And if you remember, I said that if you take equation number 1 or equation number 3, or if you take equation number 2 and equation number 3, I am going to get the same answer. We had multiplied, if you just remember over there, we had multiplied with certain numbers so that we can cancel out b and we can get the value of a. So that is the base. And what you do sometimes to get the value of a, you add to, and if you just remember, there we had done in the linear equation, we had substituted the value of a what we got, and we got the value b. Now how to do the same thing over here? So if you remember, that time I had added the rows, and I added in such a way that I am able to cancel out b, and I got the value of a and I got the value of b. This is how I had done that thing. So that transformation or that thing which we do in linear equations is putting some values in the equation that can be achieved over here by adding or subtracting the rows, or multiplying and then adding and subtracting some rows or columns. And therefore this thing is allowed. One more explanation is how can we allow this? So one more explanation is this: find out determinant of this, find out determinant of this, find out determinant of this, find out determinant of this. You will get all the determinant values as same. Okay, find determinant for this or this or this. You are going to get the same value. So since after adding or subtracting rows with rows or columns with columns, the value of determinant is not changing, hence these transformations are allowed. Similarly, when you interchange, when you are doing this transformation, which is of interchanging one, only the sign of the determinant changes, the magnitude remains the same. Suppose if we have got the value of determinant as 5, and now when you interchange and then again find out the determinant, you will get only -5. The magnitude remains same, but the sign changes when it is an interchange. And therefore, again this is also allowed. One more and last type of transformation is scalar multiplying and then adding and subtracting. So I can do something like this also. If I have this matrix A, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I can do something like this also. Say 3 R1, I am doing say R3 minus 3R1, which means I am doing transformation in row number 3. What I am doing? I am doing transformation only in row number 3. And what kind of transformation? First I am going to multiply the first row with 3 and then I am going to subtract it. So the transformation is occurring only in row number 3, not in row number 1. The transformation is occurring only row number 3. So row number 1 and row number 2 should be written as it is. 1, 2, 3, 4, 5, 6. And what am I going to do? R3 minus 3R1. So R3 minus 3R1. So 7 minus 3 into 1. So that will be 4. Then 8 minus 2 into 3. Because I am doing R3 minus 3R1. So R3 is 8 minus 3. R1 is 2. So 8 minus 6. So that will become 2. Okay, R3 minus 3 R1. So R3 is 9 minus 3 R1. R1 is 3. So that is 0. Okay, so I can do this transformation also. And once we complete with matrices, we'll go with the determinants, and there we'll see the properties related to this, which I was saying. That what happens to the values of determinant when we do this kind of transformation. Okay. So everyone has understood the transformation. So we can do 3 types of transformations: interchange, add or subtract, and multiply any row or column with any number. And then you can add or subtract with any row or column. So now that we have done with the transformation. Let's learn how to apply this transformation and get some results. So, suppose I have a matrix something like this, the same matrix which I had taken earlier 1, 2, 3, 4, 5, 6, 7, 8, 9, and I am saying convert it into upper triangular matrix. Do you remember what is upper triangular matrix? Do you remember what is upper triangular matrix? This is our principal diagonal. Elements above principal diagonal are non-zero and elements below the principal diagonal are 0. So I will have to make this element 4, 7 and 8 as 0. So when he's saying us in the question to convert it into upper triangular matrix, so what I need to do is I need to make these elements 4, 7 and 8 as 0. Okay, so this is my aim. Now I'm going to tell you one technique which is not there in your book. That is not only for upper triangular matrix, but when you find out inverse of a matrix by transformation method, there also it will be very helpful. Okay, let's see this and understand it, and if you are not understanding it at any point, then please let me know. This is very important. You are not going to find this technique in your book, and that is why please understand this properly. So now if I take this 4 and 7, these are the elements which are lying in the first column. So elements which are lying in the first column, they can be made 0 by using element of row R1, that is A11 only. You can make them 0. Using A11 only. Now, what is the problem if you don't do it? You will realize when we start doing the numerical, somehow whatever 0 you have brought over there will get displaced. Okay, somehow by doing the transformations, we are going to bring 0 over there. And if you are not following this method, then the 0 which you have brought will get displaced. And that is why you have to follow this, otherwise you will never be able to solve. Suppose I want to make these two elements 0, which are lying in column number 2. So the elements which are lying in column number 2, how to make 0 to this element? So if I want to make 0 by using transformations, okay, use A22 only. Don't use any other element. Use A22 only to make this and this 0. Use only this element to make them 0, not any other element. Similarly, if I want to make this to 0, okay, I want to make this two elements 0. So these are lying in column number 3. So for column number 3, I am going to use element A33. It's easy to remember. Column 3, A33. Column 2, A22. Column 1, A11. Please keep these things in mind. Otherwise, whatever 0 we have got, we are going to lose the sight of that. Now, when we want to convert it into upper triangular matrix, only we have to convert 4, 7 and 8 as 0. I don't want to convert other elements into 0. Why? Because he is saying me to convert it into upper triangular matrix. Okay? And therefore, Only this 1, 2, and 3. So two elements are lying in column number 1. One element is lying in column number 2. So let's make it 0. So how can I make this element as 0? Now again, this is for the first time. So I am going to show each and every step. After that, we can make our method short. Okay, to save the time and save the errors also. So can I multiply this with 4 and then I subtract with this? So if I multiply 1 with 4, it will become 4, and then I subtract it from 4, it will become 0. So that is what I am going to do. Okay, so what I am going to do over here is, from R2 I am going to subtract R1 with multiplying it with the 4. So R2 minus 4 R1. So transformation is occurring in R2 only. What kind of transformation? I am going to multiply my first row with 4 and I am going to subtract it from the R2. So write R1 and R3 as it is. That will be 1, 2, 3, 7, 8, 9. So R2 minus R4. So 4 minus 1 into 4. That will become 0. 5 minus 2 into 4. So 5 minus 8. That will become minus 6 minus 3 into 4. So that will become 6 minus 12. So that will become minus 6. Now I want to make this as 0. So I can do the similar thing. I can multiply this with 7 and then I can subtract it. So I am going to do transformation in row number 3. And what kind of transformation? I am going to subtract 7R1. So the transformation is occurring in which row? In R3 only. So write R1 and R2 as it is. So 1, 2, 3, 0, minus 3, minus 6. Now what I am going to do? I am going to subtract. I am going to multiply it with 7 and subtract. So 7 minus 7 is 0. 8 minus 2 into 7. So 8 minus 14, that is minus 6. 9 minus 3 into 7. So 9 minus 21. So 20 minus 9, that is 11. So this will become minus 12. Okay. So I've got two zeros over here. Now only this is left. And if it is in the column 2, then I should use this element. I should use element A22. So I am going to use this element to make this as 0. So now if I multiply my row 2 with 2, then I'll get 6. And then if I subtract, then it will become minus 6 minus minus plus, minus minus will become plus. So minus 6 plus 6, that will become 0. So I am going to do again transformation in row 3. I want to make this 0 and this element will rise in row 3. So I am going to do transformation in row 3. What kind of transformation? I am going to multiply my row 2 with 2. Okay, and then I am going to subtract. So it will become minus 3 into 2. So minus minus will become plus. So minus 6 plus 6 will become 0. Okay. So I will get A is approximately equal to. So I will do R3 minus 2 R1. So transformation is taking place in R3 only. So R1 and R2 as it is 1, 2, 3, 0, minus 3, minus 6. Now R3 minus 2 R1, so 0, minus 2 into 0, so that will be 0. Suppose if I would have used R1 element, okay, I would have used R1, it's easy, just multiply it with 3, it will become 6 and then add, it will become 0. Then what would have happened? I would have multiplied this also with 6 and the one which I would have got, which I got over here 0, then 0 minus 6, I would have got 6 over there again, minus 6. So by doing a lot of work, we got 0 over there, and that 0 would have got displaced. And therefore, we have to be very cautious when we are doing this row transformation or column transformation. So let's do this. So then R3, that is minus 6, minus will become plus 2 into 3, so that will become 0. Then minus 12 minus 2 into R2. Value of R2 is how much? Minus 6. So minus, that will become plus. So minus 12 plus 12, that also becomes 0. Okay. So we have got the upper triangular matrix. He wanted us to convert it into upper triangular matrix. So this is my diagonal. Elements above the diagonal are non-zero. Elements below the diagonal are 0. So we have successfully converted into upper triangular matrix. Everyone has understood this? Any doubt? Any doubts? Just a minute. Okay, let's use this transformation and find out inverse of a matrix. We'll do a numerical which we have already solved, so that we already know what is the value of matrix. Okay, what is the value of that inverse of a matrix. This time we are going to use method of transformation and we are going to find out inverse of a matrix. So let's take the same numerical which we started today in the day, that is 1, 3, 2, 3, 1, 2, 1, 2, 3. So I have this matrix. We have already found out inverse of this matrix, okay, by adjoint method, and now we'll see how to use the transform. So we have just A into A inverse is equal to I. So I write first A matrix, which is 1, 3, 2, 3, 1, 2, 1, 2, 3 into A inverse is equal to I. So I is 1, 0, 0, 0, 1, 0, 0, 0, 1. So if I convert this matrix into identity matrix, then this will become I into A inverse. And identity matrix into any matrix is going to give me the same matrix. So what we are going to do over here is, we are going to convert this matrix into identity matrix. So when we are doing transformation over here, we have to do transformation over here also. This is what the mathematics is, right? If you are multiplying or dividing something in your RHS, then you will have to do it on the LHS side also. Or if you are doing anything on the LHS side, you will have to do it on the RHS side also, so that the equation, the original meaning of the equation does not change. So for that reason, whatever transformations we do over here, the same transformation we will have to do over here also. What we are going to do? We are going to convert this, okay, matrix into identity matrix, which means this time we have to make this 0, we have to make this 0, and we have to make this also 0. Okay, you can see here. And all my diagonals should be 1, 1, 1. So that I'll get over there an identity matrix. So let's see the transformation method. So whatever transformations we have done, the similar transformations we will have to use and we'll have to convert this into an identity matrix. Now there's two elements lie in column 1. So for column 1 you have to use A11. So this is also 1, 1 minus 1 will give me 0. So I will do R3 minus R1. So when I do R3 minus R1, transformation is occurring only in R3. So I write R1 and R2 as it is. So this will be 1, 3, 2, 3, 1, 2, A inverse. Same over here also. 1, 0, 0, 0, 1, 0. Okay. Now what I'm going to do, R3 minus R1. So 1 minus 1, 0. 2 minus 3, minus 1. 3 minus 2, plus 1. So here 0 minus 1, minus 1, 0 minus 0, 0, 1 minus 0, 1. Next, I have to make this 0. So again for this, I will have to use A11. So I'll multiply this with 3 and then I'll subtract. So I will write R2 minus 3 R1. So the transformation is occurring in row number 2 only. Now since the transformation is occurring only in the second row, write R1 and R3 as it is 1, 3, 2, 0, minus 1, 1. Here 1, 0, 0, minus 1, 0, 1. Okay. Now I'm going to do R2 minus 3 R1. So 3 minus 1 into 3. That is going to become 0. 1 minus 3 into 3. So 1 minus 9. So that is going to be minus 8. 2 minus 3 into 2. So that is 2 minus 6. So that will be minus 4. Here 0. Okay, minus 1 into 3. So 0 minus 3, minus 3. 1 minus 3 into 0, so that will be 1 only. 0 minus 0 into anything, so that is going to be 0 only. So now I will have to make this and this 0. So before that, we have to convert it into identity matrix. So this also should be 1. Okay. So I can do one thing is I can divide it by 8 and make it, I can divide it by 8 and make it 1. Then I will have 3 by 8, 1 by 8 over 1 here also. Or I can do something else also. I can multiply it with 3 and then add this 3. So this will become minus 8 plus 9, that will become 1. So it's your choice. I will tell you to avoid this dividing kind of a thing. Because if you divide it by 8, so here you will get 1, but here you will get 1 by 2, and here you will get minus 3 by 8 and 1 by 8. So the moment fraction comes, so whenever you are adding or subtracting something, it will reduce your speed. And remember, we have less time. It is going to reduce your speed. Okay, don't think that this is not. We are going to use similar method to solve linear equations. Therefore, we will have to think of our speed also. Okay, so I will tell you to avoid it. It can be done by that method also, but subtracting fractions every time will reduce your speed and may increase your error. So what I am going to do over here is, I am going to multiply this first row with 3 and then I am going to add. But if I do like this, what will happen? If I do that, so here I will get 1, but my 0 will get displaced. So instead I can use this. Okay, instead I can use this. I can multiply, say it with 7 Okay, and then I can add it, sorry, subtract it. So minus minus will become plus. So minus 8 plus 7, or I can, then I'll get minus 1, or I can, here I can multiply it with 9 because here I have 0. So 0 and 0. My 0 is not going to get displaced. So I can multiply here with 9, and then minus 8 minus minus will become plus. So minus 8 plus 9 is going to give me 1. Okay. So let's do that. So what I'm going to do is, I'm going to multiply row number 3 with 9, and I'm going to subtract it from R2. So the transformations are occurring only in R2. So write R1 and R3 as it is. 1, 3, 2, 0, minus 1, 1. A inverse is equal to 1, 0, 0, minus 1, 0, 1. Okay. So R2 minus 9 R1, so 0 minus 9 into 0 is going to give me 0 only. Then minus 8 plus 9, that is going to give me plus 1. Then minus 4 minus 9. So minus 4 minus 9 is going to give me minus 13. 1, 3. Minus 4 minus 9. Okay. So now I can add this 2 and I'll get 0 over here. Now I want to make this 2 element 0. Now these 2 elements lies in column number 2. For column number 2, you have to use only A22 for the transformation. So R3 plus R2. So the transformation is occurring in R3 only. So write R1 and R2 as it is. So 1, 3, 2, 0, 1 minus 13. A inverse is equal to. Okay, we forgot to do calculation over here. So first let us do calculation over here. So R2, 0 minus 9 into 0. Here we had minus 3 minus 9 into 1. Minus minus will become plus. So minus 3 plus 9, that is going to give me 6. Okay. Then 1 minus 0, so that is going to give me 1 only. Then 0 minus 9, so that is going to give me minus 9. So I'm going to do transformation in R3. So R1 and R2 are the so 1, 0, 0, 6, 1 minus 9. So now R3 plus R2, so 0 plus 0, that is 0, minus 1 plus 1, that is 0, and 1 minus 13, so that will be minus 12. Over here R3 plus R2, minus 1 plus 6, 5, 0 plus 1, that is 1, 1 minus 9, that will be minus 8. Okay, now we have to do this 0. So I'll multiply this with 3 and then I'll subtract. So I can write R1 minus 3 R2. So I'm doing transformation in R1. So since I'm doing transformation in R1, okay, therefore my R2 and R3 as it is. So this will be 0, 1 minus 13. This is 0, 0 minus 4. Over here, 6, 1 minus 9, 5, 1 minus 2. Now R1 minus 3 R2. So 1 minus 3 into anything into 0, that's why I get 1. 3 minus 3, that will become 0. 2 minus, okay, 3 into 13. So minus minus will become plus. So 2 plus 39. So that will become 41. Okay. And over here, R1 minus 3 R2. So 1 minus 18. So 1 minus 18, that will be minus 17. 0 minus 3, that will be minus 3. And 0, okay, minus 20, minus minus will become plus. So this will become 27. So I've got here also 0. Now I need to make these two things as 0. And this I need to make 1. And this 2 I need to make 0. Okay. So now when I want to make element this is 0, I will have to use this element. Okay. So first let me reduce this. So 12 threes are because this 41 is a very big number. And if I make it 1 and then I go to subtract that, then I will get a very big number. So 12 threes is 36. So I can do 41. So I can do R1 plus 3 R3. Okay. So when I do plus, the plus minus is minus only. So this number will become little bit smaller. Okay. So I'm going to do R1 plus 3R3. Okay, I am doing transformation of column number 3. So I should use R3 only, that was the element A33. Otherwise, the 0 which we have obtained up till now, that 0 we are going to lose. And that I don't want. And that is why. Okay. So R1 plus 3R3. So 1 plus 3 into 0. That is going to give me 1 only. 0 plus 3 into 0. So again that is going to give me 0 only. 41. Okay. Plus 12 into minus 12 into 3. So 41 minus 36. Right. So that is going to give me 5. 41 minus 36. So that is going to give me 5. So transformation was occurring only in R1, so R2 and R3 as it is 0, 1, minus 13, 0, 0, minus 12. Here also 6, 1, minus 9, and here 5, 1, minus 8. The same operation we'll have to do here also. So R1 plus 3 R3, so minus 17 plus 5 into 3, so minus 17 plus 15. That is going to give me minus 2, minus 3, plus 3. So that is going to give me 0, then 27, okay, minus 8 into 3, so that is 24. So 27 minus 24, that is going to give me plus 3. Now, before making this 0, again that 13 is a bigger number, I am going to do the similar thing. Okay, it is in the column number 3, so I am going to use A33, I'll add, instead I'll subtract, so minus 13 minus 12 will become plus 12. So minus 13 plus 12 will give me 1. Okay. And then or else let me make it as 1. Let me get 1 over there. So to get 1 over here, I can just subtract. So I'm doing R3 minus R2. So when I'm going to do R3 minus R2, I'm going to do transformation only in R3. R, R. So R1 and R2 as it is 1, 0, 5, 0, 1, minus 13, and here minus 0, 3, and here 6, 1, minus 9. Okay. So I'm going to do R3 minus R2. So 0 minus 0, that is going to be 0, 0, minus 1. Okay, the display. We'll have to bring fractions. I was trying to find out a way by which I cannot bring the fractions, but here with fractions we cannot do it. I was just thinking, let me not get the fractions, but now if I'm doing R3 minus R2, so 0 minus 1, that will become 1 over there. So the 0 which are displaced, the 0 which I have got is 1 over there. So now this operation. Otherwise, I am going to lose this 0 which I have got. So it's better, which I was thinking to do naturally. I was hesitating only because I was going to get fraction, but now I have no option. So I am going to do R2 minus R3. So the transformation is going to occur only in R2. So R1 and R3 are the 1, 0, 5, 0, 1 minus 12. And over here minus 2, 0, 3 and 5, 1 minus 8. Okay, so let's do R2 minus R3. So 0 minus 0, that is going to give me 0. 1 minus 0, that is going to give me 1. And minus 13 minus minus 12. So minus 13 plus 12 is going to become minus 1. Similarly here R2 minus R3. So 6 minus 5 is going to give me 1. Is going to give me 0. And minus 9 plus 8 is going to give me 1. Minus 9 plus 8 is going to give me minus 1. Now, if I want to make this and this 0, and if I want identity matrix, I want here 1 also, so I will have to divide. Okay. Oh, since I have done mistake. Here it is 0. Sorry, by mistake I wrote 1 over there. Here I will have to divide it by 12. So I will write minus 1 by 12 into R3. So the transformation is occurring only in R3. So R1 and R2 are this is 1, 0, 5, 0, 1, minus 1, 0, 0. Minus 12 divided by minus 12 will become 1. And here the transformation is occurring only in R3. So R1 and R2 as it is. Now here it will become 5 divided by 12, 1 by 12 and minus 8 by 12. So 4 2s are 4 3s are. So that will be minus 2 by 3. Okay. Now if I just add this minus 1 plus 1, I will get 0. So I am going to do that R2 plus R3. So when I do R2 plus R3, okay, when I do R2 plus R3, I am doing transformation only in R2. So R1 and R3 as it is. So 1, 0, 5, 0, 0, 1. Over here minus 2, 0, 3. And 5 by 12, 1 by 12, minus 2 by 3. Now R2 plus R3, so 0 plus 0 is 0, 1 plus 0 is 1, and minus 1 plus 1 is 0. And here 1 plus 5 by 12, so 1 plus 5 by 12, so that is 12 plus 5, that is 17 by 12. Then over here 0 plus 1 by 12, so that will be 1 by 12, and here minus 1 minus 2 by 3. So that become minus 3 minus 2 minus 5 minus 5 by 2. I was avoiding fractions, but somehow those fractions have come. Now we have to make this 0. And again it is in the column 3. So I have to use a 3, 3 only. If I am not doing that, then whatever 0 I have got will get displaced. Okay. So do that. Multiply this with 5 and then subtract. So I will write R1 minus 5 R3. A inverse into this. So I am doing transformation in R1. So R2 and R3 are 0, 1, 0, 0, 0, 1. And over here 17 by 12, 1 by 12, minus 5 by 3, 5 by 12, 1 by 12, minus 2 by 3. Okay. Now R1 minus 5 R3, so 1 minus 5 into 0, so this will remain 1 only, 0 minus 0, that will remain 0 only, and 5 minus 5, that will become 0. Now over here, it will become minus 2 minus 5 into R1, which is nothing but 5 by 12. So 12 into 2, 24, minus 24, minus 25, that is minus 49 by 12. This will be minus 49 by 2. Okay. Then 0 minus 5 into 1 by 12. So that will be minus 5 by 12. And then over here 3 minus 5 into minus 2 by 3. So minus minus will become plus. So 3 into 3, 9, 9 plus 10, that is 19. So this will become 19 by 3. So this is I into A inverse is A inverse. So you get the value of A inverse as minus 49 by 12, minus 5 by 12, 19 by 3. So this is the value of your inverse. Okay. So if you just remember the same numerical we have done by adjoint method. So much less time it took, errorless, only you have to go on the formula, it saves time, space and everything. Here it takes a lot of space, it takes a lot of mind, and there are a lot of chances of doing an error. And mistakenly if you do somewhere error, it is very difficult to find out the error. If the error occurs, then it's better to start from zero rather than finding out the error, because it will take the same time. So this is finding out inverse using transformation method. So in the board exam, there is a question where they say, okay, you have to find out inverse using this transformation method. Then you cannot use adjoint in the board. But whenever we do JEE, you must have understood by now why we use adjoint method and why we don't use this method. Even when we are going to solve the linear equations, which we are going to see the next topic, okay, there also we are going to use echelon form. Yes, we will have to use transformations, but what you have seen now is called as normal form. What it is called? Normal form. So what happens in the normal form is we are converting this given matrix we have converted into an identity matrix by using row transformation. So whenever you use row transformations or column transformations or combination of both and convert a given matrix into an identity matrix, then it is called as normal form. Okay. We'll see one more thing is echelon form. So the very first numerical I did, where I said converted into upper triangular matrix. So whenever we are converting the given matrix into upper triangular matrix, it is called as echelon form. Okay. Converting a given matrix into an upper triangular matrix is called as echelon form, whereas converting the given matrix into an identity matrix is called as normal form. So we don't use normal form. You have seen this, how much tedious, how much time consuming, how much error prone, okay, the method is, and how much complexity it increases. Again, but you can make it compact. As it was first time I did this steps, I can do these 2 steps together, this 3 steps together, and this 3 steps together. Then it will become compact. You are allowed to do 2 or 3 steps together, but that is advised only once we are very much comfortable with matrices. So everyone has understood this. We have already found out the value for this. You can just take 1 by 6 from outside. Okay, you can take 1 by 6 common. So 1 by 6 will come outside. So this will become minus 49 by 6, minus 5 by 6 and all. And you can compare it with the answer which you have already gotten. So we have seen upper triangular matrix which is called as an echelon form, and we have seen this which is called as the normal form, and which is a very tedious and a long method for finding out the inverse of a matrix. Now let's see how to solve a simultaneous equation, and that also of three variables which were talked about when we started with the chapter. Suppose I have x plus 2y plus 3z is equal to 8. Okay. The next 2x plus 4z is equal to 6. X plus y plus z is equal to 4. So I have these three equations, three unknowns, therefore three equations, and I want to solve this, but not by normal method, because by normal method it is very tedious and time consuming. So let's solve it by matrix method. So if I want to solve it by matrix method, the very first thing what I need is to write this in matrix form. So what I'm going to do is I'm going to write it into the matrix form. So in one column I'm going to write the coefficients of x, coefficients of y, coefficients of z. So coefficient of x 1, 2, 1. Coefficients of y 2, 3, 1. Coefficients of z 3, 4, 1. Okay? And then I'll write here x, y and z. And then equals to, and then you have 8, 6, 4. So I'll write 8, 6, 4. The given equation I have written in the matrix form. So just multiply this matrices, you will get the same equation. Okay? So now to find out the value of x, y and z, we'll do a very simple thing. What is that simple thing? Convert it into upper triangular matrix. That is, you have to make only these things as 0, not anything else. So let's do it. So this can be done R3 minus R1. So the transformation is occurring only in R3. So R1 and R2 as it is 1, 2, 3, 2, 3, 4. 1 minus 1, 0. 1 minus 2, minus 1. 1 minus 3, minus 2. Okay? R2 and R3. R1 and R2 as it is, so this is 8 and 6. So 4 minus 8, so that will be minus 4. Now I have to make this 0. So to make this 0, I can write it as R2 minus 2 R1. So the transformation is occurring in R2. So R1 and R3 as it is 1, 2, 3, 0, minus 1, minus 2. Similarly, 8 and minus 4. So 2 minus 2, 0, 3 minus 4, minus 1, 4 minus 6, minus 2. Okay, 4 minus 6, so that is minus 2. Over here, R2 minus 2 R1, so 6 minus 16, so that is minus 10. Okay, so now I just want to make this 0, nothing else. So if I just subtract this, so I will get that I'm going to do R3 minus R2. The transformation is occurring only in R3. So R1 and R2 as it is 8 minus 10. So 1, 2, 3, 0 minus 1, 2. 0 minus 0 is 0. Minus 1 minus minus will become plus. So minus 1 plus 1, that is 0. Minus 2 Okay, plus minus plus with this will also become 0. And over here you will get minus 4, okay, plus 10, so that will become 6. So now we are going to expand R1, we are going to multiply this and this. So when I multiply this R1 with this, so I'll get X plus 2Y plus 3Z equals to, here how much it is? 8. Then when I expand this row with this column, so I'll get 0, so I'll get minus Y plus 2Z, okay, is equals to minus 10. And when I do like this, so from here I get Z is equal to 0. Because this is the entire thing is 0. Okay. So if I put, or instead I could have taken some other number, then I wouldn't have got 0 over there. Just I change one number so that I don't get 0 over there. Suppose if I do 3 over here, this will become 3 over here also. This will remain 3 over here also. Now when I do like this, R2 minus 2 R1. So 3 minus 4. So that will become 7. This will also become 7. Now when I do R3 minus R2, so this will become minus 2 plus 7, so this will give me 5. Okay, so now I don't have to assume anything over here. So I'll get 5Z is equals to 6. So from here I'll get Z is equals to 6 upon 5. When I substitute this value of Z over here, okay, when I substitute the value of Z over here, I'll get the value of 5. Okay, minus 5 plus 7 into Z is 6 by 5 is equals to minus 10. So it will become minus 5y plus 42 is equals to minus 50. So I'll get 5y is equals to 50 plus 42, which is nothing but 92. So I'll get y is equals to 92 by 5. So when I substitute this value of Z and this value of y over here, so now I know the value of Z, I know the value of y, I'll get the value of x. Okay, so this is how we can use this method of matrix to solve the linear equation. In the next class, we'll see two more things, that how many solutions I can have. Can I have unique solution, infinite solution, or no solution if I'm writing 3 equations? What is the rank of a matrix? And are the equations consistent or inconsistent? And if consistent, then how many solutions does it have? Unique solution or infinite solution? Okay, and then we'll start with the GW numericals. Okay, have a nice day ahead.
Thank you, sir.